Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P16E2, refers to a PGM-FI-ACG LIN Communication Error, specifically indicating a communication failure within the linear interchange LIN bus system related to three key components: the powertrain control module, PCM, the alternator, and the battery sensor. The alternator serves as a critical component in charging the vehicle's battery and is located at the front of the engine compartment, while the battery sensor, positioned near the battery, monitors battery performance. The PCM, often found under the dashboard or near the engine bay, coordinates communications across various vehicle systems using LIN communication. In operational terms, LIN is a protocol used for communication in automotive electronics, allowing multiple components to exchange information efficiently. When issues arise in this communication line, as indicated by the P16E2 code, the vehicle may exhibit related symptoms impacting performance and functionality. The DTC P16E2 indicates a failure in the LIN bus communication, essential for the coordination between the powertrain control module, the alternator, and the battery sensor. The powertrain control module acts as the central hub for vehicle control systems, while the alternator is responsible for generating electrical power during vehicle operation, and the battery sensor monitors the health of the vehicle's battery. The LIN bus allows these components to communicate data regarding battery status and charging processes, which is crucial for maintaining optimal vehicle operation. When the LIN communications fail, it disrupts the interaction between these integral components, leading to stored error codes like P16E2. Confirming the existence of this error code is often done through specialized tools, leading to further diagnostic steps to determine the underlying cause. Several factors could trigger DTC P16E2, the first being a loose connection at the alternator's plus B terminal. Such a loose terminal can disrupt the flow of current necessary for the operation of the LIN bus. Additionally, poor connections throughout the electrical system can result in intermittent communication failures. The integrity of these connections ensures that signals are transmitted accurately and without interference. Another possible cause includes a malfunctioning powertrain control module, which may not communicate correctly due to internal faults. Since the diagnostic steps require systematic verification, addressing these potential sources is key to troubleshooting the error effectively. The symptoms associated with DTC P16E2 manifest as warning lights or indicators on the dashboard, alerting the driver to potential engine or electrical issues. Inconsistent battery performance may also be noticeable, meaning the vehicle might have trouble starting or maintaining power when stationary. Such symptoms indicate underlying problems with the charge and electrical distribution systems that are critical for vehicle operation. Additionally, reduced vehicle functionality can arise as various systems reliant on the communication between the alternator, battery, and PCM may not perform optimally. Recognizing these signs early can be essential in preventing further issues and ensuring safe vehicle operation. The first troubleshooting step for addressing DTC P1602 is to start by turning the vehicle into the on mode, allowing the electrical systems to initialize. Following this, the next action involves utilizing the Honda Diagnostic System, HDS, to clear any stored DTCs. Clearing the DTCs is crucial, as it resets the diagnostic data and allows you to see if the error reoccurs. After this, the vehicle should be turned off and then back to on mode again after a brief period of 10 seconds. The HDS should then be checked again for any pending or confirmed DTCs. If DTC P1602 reappears, it indicates that the failure is consistent and further diagnostic steps are warranted. In this second step, it is essential to recheck for any additional pending or confirmed DTCs using the HDS once again. One particular code to be vigilant about is DTC P16E2, which indicates a communication error with the battery sensor via the LIN bus, a similar fault that could compound the existing problem. If DTC P16E2 is present in conjunction with P16E2, it signals a potential problem area that could involve the battery sensor or associated wiring. If neither DTC is confirmed, it suggests the system may temporarily be functioning correctly and that intermittent failure may need to be examined more closely. Understanding these interdependencies is crucial for accurate diagnostics. In the third step of troubleshooting DTC P16E2, the vehicle must first be turned to the off lock mode. Following this, the alternator 1P connector should be disconnected to isolate the component from the system during testing. The next action is to check for continuity between designated test points with the multimeter. This involves measuring continuity between test point 1, which is located on the alternator connector, and test point 2, which is connected to body ground. Performing this test whilst confirming that the vehicle's electrical systems are completely powered down will ensure there are no falsified readings due to live circuits. If continuity exists, it means that the connection to ground is intact, and you can proceed to subsequent troubleshooting steps. In the fourth troubleshooting step, the SCS supplemental circuit system line must be jumped using the HDS to simulate a test condition, and waiting for over a minute allows the system to stabilize for accurate readings. Continuity checks will then be performed between the alternator 1P connector and body ground, while sequentially disconnecting other critical connectors, the PCM connector A and the 12-volt battery sensor connector. This step is designed to determine if the LIN communication line has a fault or if it remains intact. If connectivity is interrupted upon disconnecting a specific connector, this indicates the wiring is working correctly, thus highlighting that the disconnected component requires replacement. Conversely, if continuity persists across all checks, the next steps must focus on identifying potential shorts in the LIN wiring. In this fifth step, after ensuring that all previous checks are complete, reconnect the alternator 1P connector to provide power back to the alternator. Subsequently, disconnect the 12-volt battery sensor 2P connector to isolate it during testing. The next essential task is checking for continuity between the test points on the battery sensor while the vehicle remains in the off-lock mode. The aim here is to verify whether continuity exists between the test points, indicative of a sound connection. If continuity is confirmed, the alternator itself likely needs replacing, as it is no longer performing its required function effectively. If there's no continuity detected, the troubleshooting should progress to analyze potential faults in the wiring further upstream. Here in the sixth troubleshooting step, begin by jumping the SCS line again using the HDS like in previous steps, and allow for more than 1 minute for the system to stabilize before proceeding. Disconnect the alternator 1P connector and the PCM connector A. The focus will now be to check continuity between the designated test points in a completely powered down state. By maintaining a systematic approach in cutting off power, it ensures that handling or reading connections does not produce any misleading results. Verifying continuity between specified test points not only checks the integrity of the LIN wiring, but also isolates where potential faults could lie. If continuity checks reveal integrity in the LIN wire, additional diagnostic checks involving reviewing authorized service data or possibly substituting a known good PCM for testing may be considered vital. In the 7th troubleshooting step, the vehicle must be turned off completely, and the SCS line jumped, as previously done in earlier diagnostics. This particular routine aids in preparing the system for accurate continuity checks, as it isolates the circuitry once again before testing. Disconnect the essential connectors, including the alternator 1P and the PCM connector A, 50P. The next action is to measure continuity between assigned test points under the off condition of the vehicle. This repetition is designed to confirm whether there is a solid connection in the LIN communication line. If it shows continuity, the indication suggests that the wiring is properly configured, thereby advising the necessity to replace the alternator, which was previously suspected of malfunctioning. In contrast, if continuity fails, it points to an open circuit fault in the LIN wiring, reinforcing the diagnosis of a compromised connection needing immediate repair. The final step in the repair process for DTC P16E2 necessitates confirming that all repairs have been successfully executed and that any faulty components have been replaced appropriately. Once all actions are completed, the next critical action is to clear the DTCs once more, utilizing the Honda Diagnostic System HDS. This clears any lingering error codes from the vehicle's memory and allows for a fresh check on the system's performance. Following this, it is imperative to retest the vehicle's functionality to ensure that the issues have been resolved and that all components are communicating effectively. This final verification solidifies that both the wing communication and overall electrical systems are operational, contributing to the vehicle's reliability and safety. To prevent recurrence of DTC P16E2 and maintain vehicle integrity, implementing a preventive maintenance routine becomes essential. Regular inspections of electrical connections, specifically at the alternator and associated terminals, can help identify loose or corroded connections early. This proactive approach aids in maintaining good electrical flow, ensuring optimal system performance. Furthermore, keeping the alternator in good working condition guarantees that the battery receives appropriate charge levels, preventing future communication issues. It is also advisable to periodically check the overall health of the battery, as battery dysfunction can directly impact system communications. Following these maintenance actions will help ensure the longevity and reliability of the vehicle's electrical systems. In conclusion, recognizing and addressing the symptoms associated with DTC P16E2 early on is crucial for maintaining the vehicle's operational integrity. Performing thorough diagnostics using the Honda Diagnostic System is essential for accurately determining the cause of the communication error, whether it's a loose terminal, poor connection, or faulty component. Following a structured approach ensures that no detail is overlooked, leading to effective repairs and resolution of the issues. By also adhering to a regular preventive maintenance schedule, vehicle owners can mitigate risks associated with electrical failures, preserving the vehicle's performance over time. Keeping the vehicle in optimal condition is paramount, and taking these steps will contribute to a long-lasting and trouble-free ownership experience. Please like and subscribe to the channel. See you next time.